Alright guys, so today we're going to begin the next unit of our proportional reasoning called dimensional analysis. Dimensional analysis, simply put, is the fastest way to convert between different units of measurements. Here's the definition right here. It's called the strategy for converting measurements from one unit to another by multiplying by a string of conversion factors. I want you to think today, whenever you see a dimensional analysis, all you're doing is you're going to be multiplying fractions. Multiplying. Multiplying fractions is the key component of dimensional analysis. Here's a cheat sheet that I created for you, our conversion table. If the sub's in the room or if I'm in the room, I'm going to pause it and have you copy this down. I'm not going to make you memorize this table, but there are a couple that you should know by heart. For example, the first one, every 1 centimeter is equivalent to 0.3937 of an inch. Every 1 inch is equivalent to 2.54 centimeters. Most of you already know that in 1 foot there are 12 inches. You should also know that there are 5,280 feet in 1 mile. For those of you that are my knowledgeable team, you know that there are many questions that come up that deals with miles and feet. Other common units of measurement is that there are, for every 1 gallon, there are 3.79 hundredths of liters. And then obviously 60 seconds to 1 minute, 60 minutes in an hour, 24 hours in a day. In a regular year, there are 365 days. So don't worry if you can't copy this down, all of it at once. I'm going to post this video on my website. You can watch it again and pause it yourself. I'll also try to post this document on my website. So whenever you guys are ready, just let the sub know, and he or she will push play. Okay. So next we're going to do 10 inches to centimeters using dimensional analysis. There are a couple ways to do this without using dimensional analysis, but I'm going to start you guys off with simple conversions, and then we'll start doing multiple conversions at once. So remember that when we're doing dimensional analysis, we are multiplying with fractions. So I went ahead and set up the 2 fraction bars so you can see that. First step, just write down what they give you. So I'm going to write down 10 inches in my first fraction. I'm going to go ahead and put a 1 in the denominator just because I know that 10 inches divided by 1 is 10 inches. And then I'm going to multiply. And then here's the most difficult part about dimensional analysis, determining what you're going to put in your second fraction. The general rule of thumb is that whatever unit you have in your first fraction, especially in the numerator, for example here I have inches, I'm going to go straight across into my denominator of my second fraction and just relabel that unit, so inches. And then on top I'm going to put whatever I want that is my goal. For this case it's going to be centimeters. And now I just label the unit. I know that for every 1 inch there is 2.54 centimeters, and then I just multiply straight across. But before I really do the multiplication part, I'm going to make sure that my units cancel out. So inches in the numerator multiply with inches in the denominator cancels out, and all that's left is my centimeters. And I can quickly do the math in my head. I know that 2.54 multiplied with 10, I just move the decimal to the right once, and my final answer is 25 4/10 of a centimeters. And that's how you quickly do dimensional analysis. Okay. The key again is to cross out the units that I don't want, cancel out the units I don't want. So the second problem, I'm going to convert 355 centimeters to inches. Step 1, just write the unit they gave me, 355 centimeters. I'm just going to go ahead and put that over 1. Second step, put the multiplication symbol. Third step, right here. See that centimeter in the numerator of my first fraction? Immediately go to the denominator of my second fraction and relabel it centimeters. My goal is to get to inches, so I'm going to go ahead and put that up here. And then I'm going to decide that, you know what? For every 1 centimeter, there's approximately 0.3937 of an inch. Before I multiply, I'm going to make sure that centimeters cancel out with centimeters. All that's left is inches, and I multiply. So I'm going to use my calculator. And I already did it for you earlier, so here it is. and I can say that 355 centimeters is converted to approximately 139 and 76 hundredths of an inch. Okay. Now we're going to move on to feet to miles. So what they gave me is that I'm wanting you to change 7,392 feet into miles. So step one, just rewrite what they gave you. 7,392 feet. I'm going to put that over 1. I'm going to multiply, and here's the feet in my first fraction in the numerator. Immediately go to the bottom of my second fraction, my denominator, and relabel feet. And I'm going to put miles right here. Abbreviation for miles is just MI. And I know that for every 1 mile, there are 5,280 feet. If you notice the last couple problems that we've been working on, there's really a 1 in most of our fractions, and that's another key aspect. So I can make sure that feet cancels out with feet, and now I can do the math. I know multiply straight across, I'm going to go 7,392 feet. It's gone, so I'll divide that by 5,280 using the calculator. 7,392 divided by 5,280, and that's what I got. So that is 1.4 miles. Okay, now we're going to cover 1 mile into inches. Step 1, write what they gave me. 1 mile. Put that over 1. I'm going to multiply. Miles is up here, so I'm going to put miles is here. Now you need to ask yourself, what do we measure miles in? Well, we really measure miles in feet, so I'm going to put feet up here. But nowhere do you see inches. We're not there yet. So now we're going to have to multiply one more fraction. Feet's up here, so I'm going to go ahead and put feet down here. And then we measure feet in inches. Before I put any number, I want you to look at my setup. I got 1 mile over 1 multiplied by feet over mile, and then inches over feet. The reason why I did that is if you quickly look, miles numerator cancels out with the miles in the denominator. Feet cancels out with the other feet in the denominator, and what's left is inches. Now I'm going to go into my fraction and label the units. I know that I'm going to put 1 mile for 5,280 feet. And we measure 1 foot by 12 inches. Okay? See these two fractions back over here? These are your basic units. For every 1 mile, 5,280 feet. For every 1 foot, there's 12 inches. And then I make sure all my units cancel out that can be canceled out. And now I just multiply straight across. 5,280 multiplied by 12. This is my numerator. My denominator is just 1 straight across, so my final answer is there are 63,360 inches in 1 mile. So if you haven't seen the pattern already, there's always going to be a 1 in the fractions that you're multiplying in dimensional analysis. The reason is if you multiply the 1 mile to 5,280 feet, or the 1 minute has 60 seconds, you're going to be able to lay out all the different measurements so that you do not lose any of the measurements that you're going to need. Next, you cannot jump units of measurement. So if you're going from inches to miles, you can't skip feet. Okay? If you're going from seconds to years, you have to go seconds, hours, days, and then year. Okay? Sometimes you can even go seconds, minutes, hours, days, weeks, and then year. It gets a little bit long at first, but the moment you catch on, it's going to go by really quick. So here's another example. My question is, how many seconds are in a day? So let's just start with what we know. We know that 1 minute has 60 seconds. Why did I choose to write that? Because that's the most basic unit of time. 1 minute per 60 seconds. and I'm going to multiply that. Again, multiplying fractions. Minutes is up here, so I'm going to put minutes down there. We measure minutes into hours. We're not there yet. And then hours up here, so we got to put hours in the denominator of my third fraction, and we measure hours into days. Quickly check, minute cancels out with minute, hours cancels out with hour, what's left is days over second, which is what I want. Now let's go in and put in our unit. For every 1 hour, I know there's 60 minutes. For every 1 day, there's 24 hours. And then from here, we just multiply straight across. In my numerator, 1 times 1 times 1 is 1 day. In my denominator, 60 times 60 times 24. Quickly do that on my calculator. 60 times 60 times 24, and I get 86,400. So really, there are 86,400 seconds per day. The next question I'm going to ask you is, could I have started that differently? Could I put 60 seconds over 1 minute and then just reverse all my numerator with my denominator? And the answer is yes. That's a beautiful part about dimensional analysis. You can set up your 1 minute over 60 seconds any way you want, as long as the preceding fractions are going to start canceling out those units.